Yeah, yeah. So this is okay. Hi, good morning. Good morning. Great. Thanks, D'Souza sir, for inviting us for this talk. And we have made a very special request that we need a time slot in the first half. Why? Because our brain focus only for 40 minutes, and after that, there is some kind of decline is there. But this technology is so much important that whatever the focus time is there, that you want to spend on this particular technology, right? So today we are going to talk about 5G, the connectivity for digital India. Now the question is, I'm very sure that you have heard about a lot of 5G, and even if the mobile, there are a lot of launches are there on the 5G. So first, let's understand what this technology fundamentals are. And the second thing I wanted to, feel that is like this technology, whatever is coming up, and whatever the R&D which is happening on the Mahindra side, all of things will combine together. A lot of new innovation will come. Okay, so this is the enabler kind of technology which is going to bring a very new innovative product, and all of you will witness in coming years of time, right? Okay, so let's understand some basics, some fundamentals, right? The first about the evolution of mobile network. So what happens is that the first technology in the mobile, in the sense when I say mobile, it means wireless. Okay, when people start communicating, not with the wired connected device, wireless connected device. So that start with the your first G. We say 1G, right? Where it was kind of device which is just whatever the analog, whatever the you have voices there, that is modulated with analog signal, and the communication take place, right? In that only the voice was there was no data. The second technology which came 2G, I think all of you, India, we have the 2G launch where we can say a upgraded version of the communication which was having the fastest speed or digital. Basically the information is not modulated into the particular analog modulation, rather it is digitalized, right? And then it has also the way to send the digital information like SMS, right? We was very happy with the 2G, right? We have a Nokia phone, everything was fine. So that it was a kind of the moment where we had a landline and mobile, and that was a very big thing for us. Look, we have a mobile phone. But that time we didn't realize that, okay, what is the next is going to come. Now the third generation came, and third generation really changed everything. It was not about the voice, it was not about the SMS, it was about the communication, like we was able to have the internet there. So there from the 3G side, we started with the high-speed wireless communication, internet browsing, and the video downloading, right? Remember, whatever the video was there when 3G was there, we used to download the video in our mobile phone and we used to watch it all, right? So that was the technology which was allowing us to download the video. Now the next revolution started, where 4G, right now, what we are having the 4G. Now we are not talking about the download the video. We are talking about the streaming the video. That is the speed. So now we don't download anything. Everything is online. You have the Netflix, all the applications are there. It runs on the mobile phone. You don't need a storage. Even if now the cloud things are there, you don't store all the data. You store in the direct in the cloud. All the HD video, everything is going through stay in the cloud, and you don't download it. It's just live streaming. See the technology, how is movement things happen. Now 4G brings out the online gaming, some crystal voice, low latency. Till that point, it is also fine. But that was for the public domain, where the mass communication happens. All the users are there. They are able to, the streaming video and all this thing. Till that point, it was fine. But the next point came that how this can be used for the industrial domain, where machine need to talk, not human. Now the question is, when machine need to talk, they don't talk like this. They talk with the time bounded. For them, it's very important that when the message has to be communicated, when the message has to deliver, a time bounded communication need to be taken place. Deterministic communication has to be taken place. Then machine can talk, because machine, it's a millisecond kind of thing. If machine is not talking in the synchronized manner, whole things will collapse. whole control system will collapse. That's where the 5G has taken the birth. The 5G has taken the birth to provide ultra low latency. When you say ultra low latency, it is like communication latency which varies from 1 second, 1 millisecond. 1 millisecond is 1,000 part of the 1 second, right? So that kind of a latency network is providing is just real time. And then it also provides the enhanced mobile broadband, where what happens is like the download speed, if you see, when we talk about the 5G, we can have the download the video and all these things are fine. But with 5G, now the speed of network is going to be, 1 Gbps speed, all these things are coming up. Now going to think about the applications. Now we watch, you can see that in the 4G domain, we watch the movie. Fine. Now in the 5G domain, we have augmented reality, virtual reality, where I do something, I am talking virtually with some machine. Machine is also responding to me, and a lot of other things are happening. See the technology movement, how things happen. In the next slide, I will also show you some of the use cases, how the 5G brings the value to the life, to the society, to the application, whatever things, right? Right. So, so today is the topic of 5G. At least now you have seen that journey of communication. And thereafter, since the momentum has started, okay, this journey is not going to stop at the 5G. It will go further with the exponential speed. A lot of application is going to come. This is just start. Okay, so now understand that, you see, if any new standard comes, okay, it doesn't come like this. There is a driving force behind it. And somebody is there who really understand the driving force, come together and define something that it solves the purpose of the particular problem, right? In the mobile domain or networking domain, there is one standard called 3GPP, which is third generation partnership project. So this particular organization, what it does that is, they define, they understand the realistic problem, what is there around, and they define the technical specification. And this technical specification makes sure that whatever things are going to come, it's interoperable. Now, in the today's generation, the interoperability is the very important thing. Okay, if the interoperability is not there, the good thing from one domain to other domain or one side to another side cannot move. But if you see from the, when I'm talking on the 90 side of 90 in that terms, a lot of technology were developed for the proprietary mode. And now the proprietary mode is not anymore, right? So this 3GPP standards got released in 15 September 2019. And their primary goal was that it wanted to define the wireless communication, industrial grade wireless communication. When we say the industrial grade wireless communication, there are 5 or 6 factors are there why it is called industrial grade wireless communication, and then faster response times, right? So what 5G offers as a whole technology bundle, the first thing is that enhanced mobile broadband, where we are talking about the high volume of data transfer, right? The second thing, it talks about the critical communication, extremely high reliability, 99.999% of packet delivery rate. And this is the must requirement for industry, for control system to move to wireless. Today, as of now, all the communication, mostly all the critical communication happen with optical fiber. See, for the example, in the utility system, you see that, the power grid failure happens. How it happens that if one grid is failed, the propagation in fact is so fast, the other grid will start filling it out. Communication plays a very important role there. There is some protocol called, IC 61850 Goose protocol. Their job is that if one relay is getting failed, within the 3 millisecond of time, it has to send signal to other relay, which is maybe 20 or maybe 40 kilometers away, send the signal with that speed so that before electricity affect that particular thing, the circuit breaker happens and the whole circuit, other side of circuit is isolated. Now you see the importance of communication. The electricity, if any pulses are there, and you have a circuit breaker, if one thing fails, it's just like, you have a multi-storage building, the one thing collapse, everything is getting collapsed. That's happening in the electricity domain. So there, the communication and fast will be really important. Otherwise, if you won't break the particular isolation of the substation, then things will go bad, right? So there, the critical communication, extremely high alert is the must requirement, right? Now, now, now the second point comes is ultra reliable and low latency. So latency, what it defines? Latency defines is that signal goes from one place to another place. What is the minimum time it takes it? The less time it takes it, the more faster response will come, right? So this particular technology provides ultra low latency communication and massive Internet of Things. Okay, so why this massive Internet of Things has come? See, if you see the Industry 4.0 revolution, everybody talks about, right? Oh, this revolution, what it talks that like all the machines in the world, you can virtually connect it, data can be transferred, and it's like a seamless, not you are not making a very small kind of application, rather you are making a big application. Just for example, of Facebook, you take it. Earlier, you had a phone where you have to work with STD. It means you only can connect within in India. Then you had a ISD. You can connect with globally. See, this is the particular technology provide the connectivity. When the Facebook came, they provide a platform anywhere in the world. You don't need ISD, STD. You are just connected over internet. You can make a friend. It's a massive communication platform, massive socialization platform, right? So that was for the human. What about the machine? Machine also needs some socialization, right? So for that, this IoT things has come. So that machine can communicate, exchange the information, solve the bigger problem. Here, the massive internet provides a kind of density of device that can be connected with each other. What is the communication infrastructures are there? So that's a massive Internet of Things, right? Now let's move to the basic component 5G. Now we understood that what is 5G, what is bringing for us, what is the value of 5G. All part at least we understood, right? Now we will go a bit of insight on the 5G. Okay, I heard 5G anything. Let's go inside it. What is 5G? Okay, I'll give you very simple the building blocks of 5G so that you registered it, right? So here in the 5G, what happens is that you have a radio access network. Radio access network is what? Is basically a kind of transceiver which works in the particular frequency. I'm talking with you. So human frequency is 20 to 20 kilohertz the frequency range are there. You can hear me out, right? And there is no wired connection, so you are hearing it out, right? In the radio also is same way, right? So it's like their particular frequencies are there that communicates, as you know. Now, what happens is that there is a core network. So in the 5G term, this core network is what? It makes sure that it's a kind of combination of microservices, which is together as a core network. And it makes sure that is any devices which want to communicate, how the device need to be registered, what kind of services need to offer, all the things basically from the core network, you are going to do that, right? So in the 5G, the basic building blocks is you have a core network, you have a device, and you have a radio access network. Now, so till now, if you see that, you know, what would the technology like LTE mobile phone we are using it? It is for public domain, meaning to say that whatever the frequency band is being to use, so all of your mobile phone, every phone, it works in the same frequency band. And it is best for traffic in the sense that, see, whenever the communication take place, I will try my best to, you know, establish the communication. I won't give you guarantee. For example, some work is supposed to given to you, say that I will try my best. It means you are assuring that you will do your best, but you won't give the guarantee. Even if the doctor, any operation, they say I will try my best. Till now, the communication on the mobile phone which was happening is I will try my best. This best satisfies the need, but when it comes to machine, you say I will try my best. Machine will say why you want to try best? You give me the result. I don't need try my best because if you say try my, there is a loop here that you may not try your best also, and machine don't need such thing, right? So there then question comes is like, okay, in the current network, which is wireless networks are there or mobile networks are there, it's the best effort network. So how we can satisfy the industry need? You have to give me guarantee. I don't need a best effort. So in order to solve the problem, so there's fundamental things are there, like what insists me to try my best? What is my problem area? Let's figure it out. Let's move it out, okay? And then build a framework, the scope of communication, where I can say I can do this thing. I won't try myself, I will do this thing, right? So that's where the private 5G comes in a picture, where the private 5G is for the enterprise application, where the question is not I will try my best, the question is I will do it with 100% guarantee. So in order to build that, what happens is we have a radio, we have the core network, and then we have a device, but we are operating in the boundary of enterprise. So we are not giving outside, we are not giving anything, it's within the boundary. If you are able to scope this work, if for example, 5 people are there in the room and 5 knows, addition or subtraction, right? So you know that if anything will come addition, these 5 people will take care 100% guarantee. But if you add some 6 people who don't know, then you won't give the guarantee, right? Here the point is that the boundary is defined. And how this boundary is defined, the question comes here that is like, since this is a frequency band, so what happens in the 5G is that you will have a dedicated frequency band for this enterprise application. That will make sure that it is only for this purpose, and whatever your industrial communication requirements or device requirements are there, that is going to satisfy it, right? So that is the first kind of deployment model in the 5G, where in your house, everything, all the elements of communications are residing. So this we are saying the isolated 5G, where everything is there in your premises. But here, one challenge. The challenge is this core network is complex function. It looks like one small box, but there are a lot of functions are there, which is a kind of costly or maybe a compute intensive to host it, to operate it, or to manage it, right? Some skill sets and things are required. Then in that case, what is the other option that your user will get? The second option is that we say that, okay, you have a radio, you have a spectrum that is dedicated for you, for your communication. But whatever the complexities are there, somebody else is doing for you. So that's where this model comes, where this is hybrid type remote control a core network model, where what we are saying that is you have a radio, everything, but the complexity of the 5G is handled by the operator. So that's the second model. But still, you are able to get your 100% reliable communication, all these things, but still whatever the complexities are there, that is moving out. Just like, the car, ADAS system, right? When it comes to things like that, okay, all the system is taking care for you. Complexities are decreasing and the users have more benefit, just like that. Now, the third part of the deployment models comes is that, look, I have basically the radio part is one common radio is there. Like, it's just like you have 100 rupees note. You want to make sure that 50 goes here, the 50 rupees goes here. So this is the another mode of operation where within the existing infrastructure, within the given the network, like for example, in the first case, what happens that you need always the radio tower, everything you need it, your own, in order to have the first case, which is isolated private 5G. But in the third case, which I'm talking about, here the idea is that you have the same infrastructure, but in that infrastructure, I'm giving you some portion that you take it, you use the infrastructure, but it's just like, reservation, just like you have a train, right? You reserve your ticket, your berth, and you make sure that you have a seat available when you communicate. Similar kind of thing, the infrastructure is shared. Now, this is the basically the third type of the deployment. And the fourth part of deployment is, this is also interesting, where it says that, okay, so again, the third part deployment, you have to notice that the core, the network core, where you are going to manage your operation, it resides with the enterprises application. Now, the fourth part is a bit different, where we say the radio part is yours, and the core part is also, it's handled by the MNO. So here in this infrastructure, it's kind of you are just allocating some reservation where everything is outsourced, all the complexity of the application outsourced, but you have your own private 5G frequency band which provides a kind of communication. Okay. Now, one interesting fact I will tell you. We talk about, the 5G can reduce the latency. Let's understand how the latencies are added and how the 5G can reduce the latency, what kind of different things are there. So there is one option in the 5G that multi-access edge. Okay, I'll talk about it. Let's see that scenario. There is one device that is the sender device, and there is a device which is a receiver device. So you wanted to send the data from sender to receiver. So how it normally operates is, it operates that the sender will send the radio signal to RF, a particular radio's RAN network, and from there it will go to the core network. So DCN is not taking at the wireless radio access network. See, radio access network is a facilitator. Whatever you say, I'll give to someone. Decision makers sits in the core network. So all the communication goes to the radio, then it goes to the core network. Core network decide that whatever the person who want to send it really is there, they will validate all kind of things, and then it will again send the signal to the tower, and then it goes to the final device. Just like if I wanted to communicate with you over mobile phone, it's not like our communication is happening directly. It's like the call which I'm making again is going back, going to switching server, then identify the other mobile where it is, and then you are getting a call. So even if we are sitting just beside that, but communication doesn't happen in that way. So in this case, if you see that, there is if you talk about the network latency, so T1 time goes there, let's say T1 time, that signal communication or data goes from the sender device to the radio. Then we have a T2 time from radio to core network. Then we have a T3 time from core network, again radio, and then T4 time from radio to device. So if I see about, the total network latency is T1 plus T2 plus T3 plus T4. This is the latency we are talking about, correct? Now the question is that if you have this T1, T2, T3, T4 kind of scenario, then obviously you will have certain limit. Beyond that, you cannot decrease the latency. What is the solution for that? If I have to send the data with a low latency, but I have a T1, T2, and T3, T4 in the picture, how I can reduce it? There should be some way. Otherwise, if you won't reduce the latency, then it's not suitable for my application. For that, there is a concept called network edge. So idea in the network is that wherever the core networks are there, because as you understood it, right? Whatever the packet we transfer, it goes to core network. From the core network, the decision happens where it has to go. Now, the application can be designed in this way that we can provide a kind of the compute infrastructure besides the network edge, where you can host your application, all the critical applications. Instead of hosting the server, whatever in the T4, that you can host on the edge itself. Then what will happen if you host in the edge? Then the communication is nothing but T1 and plus T2. From the radio, it goes to the core network, and core network is connected to the edge, and information goes there. So what we are doing that we are reducing the further packet, like T3 and T4, we are reducing it. And if we are able to reduce T3 and T4, of course, we are able to offer the low latency. So the 5G concept comes with the network edge also. So when we deploy the 5G, we have an option that near to the network core, we have the server or maybe a compute space, which we are saying the edge. And there you host your whole application. You can host very dedicated server, your control system, whatever things are there, you can host it there, so that the communication path, we are reducing it. And that is the most important for the industrial application. Why? Because we wanted to reduce the latency. For closed loop application, latency is very, as I said you, right, that in the power system, the travel of electricity versus the travel of communication, the communication speed has to be faster to the effect of whatever the catastrophic of the electricity happening, that has to be faster than when it can break it. So this kind of scenario gives a very, very nicer way to solve this problem, right? Okay, I think time Twice. Okay. So you are seeing the time. You can give me the alert if something is there, right? Okay. So yeah. So this is about the network. So the point here is that the 5G solutions are there, and in this solution, the standards are put in a way that you can have your the edge computing besides the 5G, and you can load your application there to reduce the application. So as I said in the first place, that the 5G is designed to solve or to provide industrial grade problem. So in the all working group, normally working group, what they do, they are people from the different companies, different domains. They will come and they will define the requirement. I need this one for my application. This is required. All side of problem they will put it, and there is a researcher or the people who understand this thing and try to see that how the problem can be solved. Before releasing the standard, a lot of trial happens, a lot of testing happens. Okay, and that is an enormous number of effort and money goes there in order to say that yes, this qualifies it. 5G right now in a phase that this is qualified. The journey of actually the first release of 5G specifically, of course, happened in 2019, but start of thought happens in 2017 itself. It really took almost 5 years of time to define this standard, have some test cases run, test it out, and then finally conclude, yeah, this is the way that to solve the problem. Okay, so I hope you have understood the 5G deployment way, the different benefits, and the network edge concepts, right? Why it is needed. See, as an engineer, we have to always ask a question, okay? Why? Don't accept it. Any things are there, then you have to always ask a question, why? Even if like it's less like maybe some person will not give you the answer, but always keep habit of question why, because the moment you have a why questions, your brain will work to get the answers, right? Okay, so now the fourth part, I also want to touch upon it, is that since 5G was not there in the industrial domain, and still the people need a mobility solution in order to manage their requirement. Because see, the wired and wireless communication are different. Wireless communication, of course, have mobility kind of features, which is always required. For example, mobile phone, right? Mobile phone is the mobility. Earlier we had a landline. So landline, the use case of landline is very less. Of course, mobile use case is very high. So in industry also, you have a different robots and all need to communicate and all this. Some kind of wireless was required. So what happens is that people cannot wait for 5G, or 5G has own way to define it out. So in most of the applications, the Wi-Fi is being used and still is being used right now. Then the fundamental question comes that if Wi-Fi is able to solve my problem, why I will go for 5G? So here in this slide, I wanted to highlight some of the basic things. All wireless protocol provides a communication, everything they provide, but that does not solve all the specific issues. Every technology having some limitation. In this particular slide, things we will just discuss about some of the key features which set the background why Wi-Fi, 5G. Okay, right. The first use case is latency. With Wi-Fi, whatever you do, if the area is very large where you want to cover the communication, you cannot have the latency lesser than 100 milliseconds. Why? Because if you see the Wi-Fi, how it works, you have a router. The router is connected with the controller. Then there is another router, again controller. So a range of Wi-Fi is range. So multiple hops are there. So whenever the multiple hops are there, okay, there would be loss of time. It's just like in the vehicle also, right? Whenever you have gear system, you have multiple cranks and after you add it, the efficiency and performance goes down. Direct is better, right? So similar concept everywhere. This is the same concept. You have to reduce the multiple hops. So in Wi-Fi, we have a lot of hops because the range is limited. In order to have the large range, you need to have multiple device, multiple hops. Multiple hops means multiple latency will be added. So that's the reason. And in the 5G, we don't have multiple hops in a way that one radio tower can cover up to 40 kilometers. Okay, I mean there are different deployments, and I'm just giving the figure of the capability, but it differentiate whether the area is rural, dense, or it's urban area. So those kind of equations are there, but just we need to understand that the range of the communication of the radio is different. Why it is different? Because the frequency that it operates, see, and then whatever technologies are being used, so that gives the more range there, right? Now the question is reliability. So reliability talks about the assurance. Whatever I have transferred, I make sure that it is received. The assurance is reliability. And in the private 5G case, the reliability is very, very high. 99.99% reliability is given. That's a tested. But Wi-Fi case, the reliability is not the case. Why? Because why is not there? Let's understand it. See, Wi-Fi is working in unlicensed frequency band. Bluetooth, Wi-Fi, microwave, if you see, it's generated the same kind of frequency. So it's create a lot of noise. And when the signal is having a lot of resistance and noise, there would be delay. There would be reliability failure. There is a packet failure would be there. When the packet failure is there, the reliability will decrease. So it's a very fundamental physics, nothing else. In this technology, this is there. See, just like, if you are going in the road where a lot of traffics are there, of course you will reach late or maybe you will delay. But the way the road is kind of free, you have fixed time. Yeah. So the third point is about the mobility. This is very important concept. Today, you can have the mobile phone. I'm coming from Bangalore. My mobile phone is switching now connected to Chennai. Even if I go anywhere in India, my mobile phone is connected and operative. I have the mobility, not only in India, even if I went Germany, there also my networks are there. Because mobility, all the equipment and things are working across pan India or across the world. So the mobilities are very important. In this private 5G, we have a mobility, larger area to roam around. But in the 5G case, Wi-Fi case is kind of fixed location. For example, your home Wi-Fi is there. Your home Wi-Fi work, only in the home you go, then Wi-Fi, your device connects. Outside the home, it doesn't work. The location of wireless communication is fixed. But in the 5G, of course not. Now the device density comes in a picture, right? So any communication, how many devices are connected? So how many devices are connected? So that really matters. So here the density of the device connection is very high, very, very high in the 5G compared to Wi-Fi. Now the coverage. So Wi-Fi is basically used for the indoor coverage. All the communication indoor. Why indoor is best? Because see, outside communication, what is the challenges are there? In outdoor communication, you have a challenge that the storm can come, the rain can come, a lot of different frequency and things are generated. So a lot of challenges are there in the outside communication, which disrupt your communication. While in, if you see the Wi-Fi, it is suitable for indoor communication. You put in the house, things work because a lot of disturbance are not there. While in the 5G mode, it works in the both way, indoor and outdoor. So both kind of applications are being used here. And another thing is that in order to put outside, for example, you have a router is there. If you wanted to put outside, then it has to certify some norm like IP64, IP65, which talks about, it can withstand with temperature, dust, and water. A lot of casing and all these things are required. It's going to be very costly affair. If Wi-Fi has to go outside, all the router has to go outside, there are a lot of things need to be taken care. Again, this is from the industry point of view. Right? Now the security. The wireless communication. So wireless communication is like, whatever I'm saying, all of you are listening. It means there's no security. Anybody comes can listen the same thing. So the question is that how I can speak in the public forum where you can receive it, my signal, but you cannot interpret it. Listening is not a problem. Interpretation of language is a problem. If I encode my message, say some wording, that only few people can decode. Even if in the public domain, I can communicate. If some German comes and two people are talking the German language, we won't be able to understand. It's encoded. They can only understand. We can hear, but we cannot understand. So that's why security is very important. Now, in the security factor, what happens is a lot of standards are there. Uh, Sir, you have to, Mike, so you have to tell me if time things are, how much time is left? Only 15 minutes. Okay, okay. Oh, okay, then I will run fast. Okay. So anyway, the security is important, and the use case, if you see the target for industry 4.0, and important concept, the spectrum diversity. See, try to understand one more thing, very important thing, that if any application need to be designed, for example, if you need higher broadband, the whole control network and the frequency has to work in that way. If the application is to need to design ultra low reliable communication, then whole application designed to that way to meet that requirement. In 5G case, we have that possibilities that application can be configured for different kind of scenario. In Wi-Fi, it is not. IoT battery life. See, with the 5G communication, you can have a sensor which can lead to 10 years of battery life. It can operate as it is, but in the wireless case, it's not. And of course, OpEx is operational part of it. The more coverage on the Wi-Fi you have it, there would be problem, a lot of trouble, cable cut and all these things. As operational cost is going to high in case of Wi-Fi for the longer term, but with the Wi-Fi, which with the 5G is going to be lesser. And the most important part, the future-proof investment. The way that 5G is going on, the way the 5G provide a massive platform, and the way 5G will enable all of use cases, right? So the future is protected. Any investment need to be there, it could be protected. But in the 5G technology are changing very high. It's just like, 5G is more over the public domain kind of application where like your mobile phone, every year changes, new technology comes, things will be there, right? Okay, so ability I already talk about. Some use case I will talk about very. So in this particular slide, you can see that is that, do we have a, oh, this is there, right? So what you can see here is that, there are different kind of applications are there, automated guided vehicle and all this thing is working on. So the idea is that all this application can be connect with each other side of the application. For example, for this kind of application, you need a command control, right? Then this particular application connect with the 5G network and then have the backbone connectivity and then core part and then application can be configured. So just to talk about, diversity of application is that we talk about extreme broadband, massive scales and ultra low latency, right? So these are the applications area. Just to highlight it, like what kind of applications are there, which suits in these requirements, right? So if you have a virtual reality in augmented reality, a lot of bandwidth is going to consume. So you need an extreme mobile broadband kind of configuration. But when you talk about the massive communication skills, like a lot of wearables are there, a smart band, a smart helmet, and all these things. There, the amount of data is very less, but the number of devices is very high. So that's a massive IoT platform that will solve. And then ultra reliability, low latency services, which is public safety, remote surgery, vehicle, and then the vehicle-to-vehicle communication, industrial automation. There, the latency is the most important criteria. Now we are talking about the virtual surgery, right? Remote surgeries. In remote surgery, you can understand if the command is in machine don't understand, the operation will fail. So latency is very important. Otherwise, you cannot have such kind of service. It's a life-threatening thing, right? So this point here, the point need to be understand that is that the 5G has the service diversity. You can tune your 5G, private 5G for all to meet all different kind of application requirements, right? I mean, just it's like thoughts on the table, right? What kind of application you can think about from the 5G? The first point, this is the very good cases which will be applicable in Mahindra as well. That what happened that there is a skilled technician, and there is a problem scenario. You have a plant, you have a skilled technician, and their problem occurs. The problem for the skill, like in any company, a skilled technician cannot travel to remote area to access all kind of devices or to solve the problem, right? This is a bigger problem. Now what is happening is that, okay, now with 5G and augmented reality assisted maintenance framework kind of thing, that a skilled person is sitting at one place only, an unskilled person who is just aware of switch on and switch off button, he has the smart helmet in the place. The live image of whatever things are is he is able to see here, and he is controlling. Okay, now you switch on, switch off, whatever things are there. He's virtually he's doing that. Basically, hand is unskilled person, and brain and all these things are skilled person. And with this 5G, in the real time, he can solve the problem. Okay, so that's the one kind of use cases that you can think about. Uh, Now, second kind of use cases, this is also very important, which is a kind of, the paint defect. For that also the POC also done, we will cover it out. So this is the scenario just to again highlight, the idea behind this is that just highlight the application scenario so that it is a kind of thought in the brain, you can correlate the future use cases, okay, and in the industry. So here you can see that, the car is there and then car is going through the camera scanner where HD cameras are there and they are scanning it out. All the images are going to a local PC, which does not have high computing. Here for the camera paint detection, the computing is very important and computing is very costly. So the idea is that all the files goes there, but we have a GPU cluster on the cloud, which is Mac I talk about multi-access edge computing is connected there. So all the traffic in the real time, it goes there and it comes to a GPU cluster, whatever things need to be taken care, is go to, and then command line goes there and say that whether card paint defect is less or not. So in this case, what happens is, so you have one central place, the GPU cluster where high computing things and all the AI servers are running. And in the different plant, which has a client node, can take benefit out of it, right? Now, this is the, again, third problem where what happens is like you have the different application like pipe leakage and lubrication, some color changes are there, something happening. So the point is that all the manual inspection that we do as of now today, how that can be done using the smart camera and sensor, and then how it can be communicated the core network and different application can be enabled. So the moment we are able to capture the right data from any plant and any space, and we are able to communicate, decision making is easy. But if we are not able to send the data right time, are not able to send the other side, then communication won't take place. I mean, application will fail here, right? Now, this is another area which I talk about, where the industrial internet and then control system. So what is happening is that a lot of things are happening on the field. Information goes there with the industrial gateway, goes to 5G, and then the DCS control system is allocated outside, which has having AI capability. The point is that with the 5G, the distance, so right now all the hardware devices are co-located with each other to minimize the latency. Now with the communication, high-speed communication, all the devices can be distributed each other and can do still the same job. And the benefit is that one device can be multi-tenanted. One particular control system can be multi-tenanted in order to handle load from the different location. So the initial cost, investment, everything will go down, everything in the one location, a lot of benefits will come. Now, this slide, I may speak it. So this is the slide which Michael was also telling, that the POC that we have done in the Mahindra Chakan plant. So there, whatever the problem was there is that you have the ECU server. And with the ECU server, what is required that is that the vehicle need to be taken at the one place. So the problem scenario, what I understood that, okay, you have a manufacturing unit which manufactures the vehicle and put in the yard. On the other side, you have a distribution unit where the dealer calls for the vehicle, whatever the order this comes. When the order comes, the vehicle need to be taken from the yard and put it into the ECU server where the latest firmware is designed, and then it is shipped to the distributor. In this process, there are two challenges are there. The yard is very far than where the ECU servers are there. Now, the other issue is that whenever the vehicle manufacturing it, the order of manufacturing and stocking and the order of taking out is work in the last in, first out. It's not working the FIFO concept, first in, first out, rather it's a LIFO concept, last in, first out. In that case, what happened, the first manufactured device always there in the yard, it never gets time to take it out because of the congestion. So that's the one problem. The other problem is that it has to take from the yard and then it has to come there and things need to be done, right? So the solution part, what kind of validated is, instead of doing this flashing at the particular location, can be done outside a yard. So where the vehicle is there and there only you configure, download. You no need to bring out the vehicle near to issue server and do it. So how that is possible? So that experiment is done. What is done, that is the kind of network. So here the network, whatever the issue server data are there, that is travel to a 5G core system, and from the 5G core system, that is travel to other outside location yard. So now the communication which is happening directly here now, this is happening via this channel, and because of the 5G speed and all this thing, we have seen that we are able to configure the device, what is the vehicle successfully. ECU server things are working fine. See, one thing which understood that ECU firmware size is quite bigger size. So the real-time transmission of the packet is very important. Other problem was this ECU server is very critical data for the Mahindra, where the firmware should not be leaked outside. It should be staged in the server, and dedicated communication need to be taken place. So that was the problem. In the real time, this is transferring the data. Whatever this device is asking in real time is getting transferred over secure channel and then delivered. So the actual data remains in the ECU server, but the connectivity part taken care. So we are increasing the length of this communication to length of anywhere, and this problem is getting solved, right? So this was a POC done, and this POC done when the 5G was not launched. That was a pre-launch kind of thing that it happened. So the performance on all these things numbers also got very nice. And the second part probably, yeah. So second use case I will also cover where the painting part, like I think this is also PSC done where the paint defect. So paint defect is a bigger problem for the car manufacturer. Any small paints are there. The customer side, if any small scratch, they have ruthlessly say just no, I don't want it. The saying I don't want it for them is easy. Of course, for them also is because they are putting money, and then a small scratch is just like, you know, scratching the first car also I have a paint, right? So it's very difficult to buy a scratchy car. So it's a small effort, but the point is if it is taken care and properly inspected through the machine, not through the human can do a mistake. Machine can be controlled, right? So then the later stage problem can be solved, right? So the idea was that, okay, whenever the car is getting painted out, then it will be having the camera and all this thing, data goes to the 5G network, and then the vision server, whatever AI servers are there, which detects it, whether the image is scratching or not. So that is sitting beside the core. So in this way, what is happening, the third use case, which I talked about, the edge case, right? This was the case. So real time you have a pen data, image is capturing out, somebody is making decision outside, immediately say, no, this is the area, they need to be repainted. Just so from the plant itself, you are making decision, it's not going to customer side. Before that, the problem is getting solved, right? A huge number of savings are there because the car, if you see the cost of logistic, manual, and all these huge costs are there. It's not a small cost. So if this kind of solution works, it's really solve the problem. Now I will invite my colleague Shivalan to talk about these two use cases, what I talked about, you know, issue flashing, and so what from the Tech Mahindra side, what efforts are there? From networking side, Airtel has done, and the Tech Mahindra side, so we have a partnership. So networking solutions is done by the Airtel, and any integration side of the story, like how the actual plant data will transfer, what kind of things need to be done, what is the interface all there. So there the Mahindra, Tech Mahindra is having expertise. So this particular POC was done associated with Airtel and Tech Mahindra, and the Tech Mahindra is SI partner for Airtel. And I'm handing over to Shivalan to cover these two use cases. Thank you.
Thank you. Hello all. Hello all. This is Sivabalan from 5G for Enterprise, part of Network Services Group, Tech Mahindra. So, yeah. So yeah, we were our team experts were in touch with Mahindra Group way back from May 2021 regarding digitalization and make the enterprise network centric. So we have identified a couple of use cases that already Michael has mentioned. So finally, it was like we scrutinized and based on ROI calculations, we have selected three use cases, namely like this ECU flashing, paint job defect detection, and AGV. And we dropped the AGV case based on some valid reasons. So now, sorry. Yes. So it is like now it is the ECU flashing where the vehicles in a big yard, production yard. Earlier it was done using Wi-Fi, and there were black spots in the stock yard because there is a limitation of the Wi-Fi coverage. So what we did, we proposed a solution like we enabled those tough books 5G enabled, and you know about 5G, right? So the coverage will be even throughout the stockyard. So that we are eliminating the need to physically move the vehicle to where the coverage is good, so that without any physical movement, then and there you can upgrade the ECU firmware that will greatly improve the productivity overall. So that is one of the solution implemented. And so if you see the outcome, it is like the time taken was reduced by 20 seconds to 2 seconds, and ECU flashing overall performance improved by 15 percentage. And so it is like the overall efficiency of the ready-to-deliver vehicles were improved. So that is one use case from us. So the next one is like paint job defect detection. The issue here is like there are like 25 there were like around 25 defects per vehicle where goes undetected, and it is very difficult to detect the defects which are smaller than 1 to 2 millimeters. And there were a lot of customer and dealer complaints. To overcome this problem, we proposed like having a AML model which will be running in the edge server. So there will be a rig which is configured with around 50 plus cameras, which will be capturing high resolution frames of the car, and it will be sent to the edge server where this AML model will be processing that incoming feed and looking for defects as small as 100 microns. So it is like initially the outcome was like 87 percentage improvement, and once we fine-tuned the AML model, it went up to 99 percentage, which means virtually no defects escaping this paint detection, paint defect detection system. Yeah. So so if you see like KPIs, it is like there is an improvement of 87 to 99 percentage on the vehicle inspection time. As the whole process is automated, the vehicle inspection time went down by 50%, and in turn there is very less dealer and customer complaints. So here the on the edge server, which is running on that private 5G network provided by Airtel. So there that AML model was running, and it was like real-time inferencing was going on. And yeah, both the systems, there will be real-time dashboards where the floor managers can see the statistics in real time, and the data will be stored in the edge, and there will be edge inference so that the operators can have the insight. For example, with respect to defect detection, last 100 vehicles, what is this thing? So how many defects were there for last 100 vehicles? So last 1 week, what is the defect range? Any improvement or any any drastic difference? All those data will be coming from the edge, and you can have real-time insight because of this edge inference. So yeah, these are all the two use cases. Any questions?
Okay. Yeah. Yes. So there are two things basically. So one more use cases are there. This is on the public 5G. What happens is like, kind of again POC where some partners was there and then Airtel 5G provided. This is a very interesting use case where the remote area doctor cannot reach. So how the remote ambulance can be done where the patient is, all the sensor and things are there like a stethoscope, all the digital information is being transferred to the server, and the server where all the doctors are there, teams of doctors are there, and the case is being assigned. So this runs very successfully. They are opening up a new business use case over it. So this is that scenario. Yeah, let's control this there. Okay. And yeah, another thing, just to conclude the talk. So value proposition of the Airtel versus 5G. If you see that, so Airtel is the kind of company which owns the spectrum for the 5G. So it means that 5G works with the license band, and Airtel is having the license band, bigger portion of the license band. So any 5G, if anyone want to enable, of course, they have to go for the vendor like Airtel or maybe Jio or other company, to have the 5G ecosystem in their place. So we have biggest range of spectrum. Then for the Airtel, what we have is that we have very good partnership with the company which provides the equipment and the services. So we are the front leader, but from the our side, we have a lot of partnership with the vendor. With whatever the 5G use cases are there, we have the vendors and all this thing. We negotiate a trade-off with them and then try to provide a complete package of the solution. So we have a one place 5G solutions. Now the third part is the cloud and edge part we talk about. Again, we have a tie-up where the cloud services, private cloud, those kind of offerings. Also, we have a type how to establish and all these things. Now, the SI consultant, like system integrator. So the question is, okay, network is there, 5G is there. How we are going to interface the data? So for that, we need to have a system integrator. So we have the partnership with the system integrator and our keys value. Okay. So one more thing I just want to highlight, while coming there, I have seen a lot of presentations. So I used to go in the global conference and there I used to write a paper and all these things. So same thing I have seen there. I was very happy to see the problem statement. Somebody talks about the car diagnostic. Somebody talks about the Excel improvement. A lot of things I have seen which really kind of giving me that it's not it's a global world class kind of conference where this paper got presented and everybody is talking about. I will give you one challenge here that in the next symposium it happens, right? Try to see the power of 5G. Try to see the distributed computing and try to see the real problem. Okay. The paper should be targeted. You have now 3 building blocks. You have a compute at the one place, very high compute. You have a communication network which provides a near real-time communication, and you have a problem area. How the pain defect, how we have seen that ECU problem. This is just an eye-opener kind of use cases. But you, as an R&D engineer, you have to define new standard. You need to innovate the solutions around it, and you need to protect the solution. This is the kind of era where you need to do that. Think a bit differently, try to correlate your problem, and try to see how the 5G can help to solve your problem. Anyway, we have the Michael, and if Airtel side anything are required, if you have any problem or challenging discussion, we are always there to solve to help you out. 5G is going to be game changer in next 5 years or maybe 2 or 3 years. Just see that how many new things are coming up. Hell lot of things are coming up with the private 5G. I'm already interacting with a lot of startups who wanted to have 5G services. The level of application they are talking about is completely eye-opener. It's completely different. And this particular automatic domain, which Mahindra is doing, it's very, the domain where it's around with the specific company, a specific team. There also the innovation has to come. And with this technology, you can have innovation. With that, I want to conclude my talk. If any questions are there, I'm really love to answer them. And I'm really expecting some of the questions if you see this technology is valuable. Please.
Coming up, we have a both Airtel and Tech Mahindra. Please all your queries. Thank you very much.
Thank you so much, Ravish and Sivabalan. It was very exciting. So we learned a lot about what's the difference between Wi-Fi and 5G, why people should, and in which cases 5G is more helpful. So as Michael said, we are extremely short of time. So both of them will be with us through the day. So I would kindly request you to take the questions offline because we are running short by more than 30 minutes. So we'll eat into our lunch time. One question. Okay.
Actually, I must really thank you Ravish and team, excellent presentation and information. Very simple way you made us to understand. Thank you. Thank you for MTA. Please give us a 5 minutes MTA team because this is a very wonderful topic, which is upcoming topic. It would be better interest of the audience also. I listed down a lot of questions. Probably I can touch with you offline, but like one or two question and one suggestion also. Mainly like government of India declared and what you call a lot of broadband services, optical fiber networking across India. How that investment versus this private 5G makes the difference? That's the one question. And the second question is, and the public uses the 5G in the mobile versus machine to machine. And last, what is the impact of this to the living organisms? As a question, suggestion as a very use cases are excellent in the paint quality. Like a gap and flushness is one of the inconsistency, even with high control in the production, we see at the end of the, like when the customer receives. Do you have any opportunity from Mahindra and Mahindra to control the gap and flushness in the line and correct it there instead of coming to dealer? Thank you.
Yeah, thank you. So I see two questions, a very interesting question. Thanks for asking this question. Okay, the first question is that the role of optical fibers and all the investment which is made available, how the 5G is going to challenge them or how it's going to coexist. See, one thing will tell you. See, the communication. If you see our very generic concept, our Earth is round, okay, and signal travels a straight light. The point is that wireless cannot have a solution for long range communication. It cannot. Signal will travel like this and your Earth is like this, okay? So somewhere it will end. It won't go directly. So what happens normally is that one radio tower is the range of 40 kilometers it will cover. Now, the signal which received from the end device, it goes to the tower. From tower, optical fibers are there, which is backing to the switching network. And from there also, all the networks happen after every story is wired only through optical fiber. Okay, so wireless is for in device, but the information, the actual information which is happening to the switching server core network, that is optical fiber. Okay, so the point is this is it's always there. This is the combination of things has to be there. That's one thing. Right now, the second question you ask. Sorry, I just missed. Can you? Public versus private 5G. See, one interesting fact here, right? In the public 5G, what we do, we download the information. We watch movie, net stream, and all these things. In machine case, they upload the information. Very fundamental difference. You have a camera, upload the information to the server. You have a sensor data, upload it. But if you see in the public domain, everything you want to download it. Upload use cases are very less, right? So that's where when you upload and real-time things comes, and the public 5G where the download is given the priority, this will not match with each other. Of course, some of the application you can do that, like some monitoring kind of thing where these things are, but where the hard real-time applications are there, where you have to meet a deterministic communication, you cannot. This cannot be said. Right? I hope the answer is.
So hello, check. So just to add to this is, when you talk about private and public 5G, let's imagine that you have your vehicle testing test bed, right? And you have a machine to machine or process, communication that happens, right? Today it happens via cable, right? Or you may be using Wi-Fi connection. Now, as Ravish and Shiva mentioned, what it brings, very important is speed, bandwidth, latency. These are the kind of improvements and the kind of fast, communication from. And we talk about milliseconds, right? 1 millisecond, 2 millisecond. Are we able to get it? Yes, today. And how we are able to do it? Through wired. But can we because there is a lot of wires, all across. You go to a shop floor, okay, you come to Chakan, you go to any other location. There's a lot of, and Industry 4.0 talks about huge, humongous, data communication happening. So here we can curb this down, the 5G, to make it a private network, as well as I mentioned that, if you have to connect to the cloud, if you have to connect to various, domains, then the 5G public would come into place. To answer also that, because of COVID, in fact, the 5G rollout across pan-India and the government, norms coming in got delayed. But there is a directive from the Department of Telecommunication and TRAI that the entire infrastructure rollout should happen by the end of, please correct me if I'm wrong. So they're going to take on a fast pace and 5G is going to catch up very fast. And trust me, it's a matter of few months. By the end of December, today, Airtel is in 87 cities. Okay, not every part of the city, but very soon by the end, I mean, there are other competitors also, but all I'll say, due respect to Airtel, and this is gonna take up fast. Thanks.
Thank you so much.
Thank you.
So, small token of appreciation.
Thank you.
1 second, please. Shiva. Sorry.
Thank you so much. Thank you.